In this problem we're told we're floating at an even keel draft in salt water and with a midship rectangular deck, length and extending the full breadth of the vessel, and it's flooded with salt water to a depth of 0.5 and the height of the deck above the keel is 9.6. Using our data booklet, calculate the fluid GM and the angle of Loll. Okay, to get the GM we need the KM and the KG. So to get the KM obviously we use the tables, and what's happened here, our KG has changed because we've got this fluid on the deck. So before we go through it, let's sort of picture what's happened here. There's our vessel. I've drawn it as a box shape, but just for display purposes. We're told the height of the deck is 9.6 and we've got this salt water on deck at a depth of 0.5. The breadth of the vessel is 20.42, so we've got that from the tables. So the value in green I've got from the tables, and we're told the length 28, breadth 24, 20.42, depth 0.5. The reason they're giving you this height of the deck is so that you can work out the kg of the salt water on the deck. And remember, a kg is from the keel to the centre of the weight. So the kg of the salt water will be 9.6 plus half of 0.5, 9.85. So it's important to realise that when you're working out the kg of the fluid on the deck. And of course we're going to have free surface moments. So let's look at how we solve the problem. We go in the tables at our initial displacement, at our initial draft to get our initial displacement. Work out the weight of the water on the deck, the usual way. Work out the kg of the water, which we've just talked about, and work out the free surface moments. Then put everything in the table and you can work out your final kg, and it comes to 8.57. Go into the tables at 15450 to get the km, and at the same time get the kb, because we're going to need that for the second part of the problem. Then subtract the km from the kg and we see our fluid GM is minus 0.24. You're always going to get a minus in this answer, so for GM. So if you ended up with positive answer, you've done something wrong. So GM minus 0.24. As I say, from the tables at 15450 we got our kb 3.84. Therefore the BM for the formula for the angle of Loll is km minus kb. 8.33 minus 3.84 is 4.49. So all we now do is put that information into the formula. There's our GM carried forward, our BM put into the formula, and now we can work out our angle of Loll, 18.1 degrees. So maybe doing a sketch yourself might help you, but hopefully you can see there how we can very quickly work out the kg of the salt water on deck. And just mentioning again, the 20.42 came from the stability information booklet that we're given, the data booklet.